In this video, I'm going to show you some more examples of non-homogeneous differential equations. The first example is y triple prime minus y double prime equals 6x plus 12. Remember, the general solution, if you suppose y to be the general solution of this differential equation, the general solution is always equal to the sum of complementary solution and the particular solution. The complementary solution is the solution of the corresponding homogeneous differential equation. Homogeneous differential equation corresponding to this differential equation is y triple prime minus y double prime equals 0. So we set this side equals 0. So we have y triple prime minus y double prime equals 0. By solving this homogeneous differential equation, first we can find the complementary solution. For solving a homogeneous differential equation, first we have to write the characteristic equation r to the 3, because we have 3 prime here, r to the 3 minus r to the 2 equals 0. Now for finding r from this equation, we can factor r to the 2 times by r minus 1 equals 0. Now, if we set this equals 0 and this equals 0, we can find r. So from here, we have r squared equals 0 or r minus 1 equals 0. From this equation, r is 1, and from this equation, r is 0. But note that this 0 is not a simple root, because this is a quadratic equation. This is an equation of degree 2. R squared is 0. R squared means r times r. And because this is a quadratic equation, this solution, this answer is not a simple solution. This is actually a repeated solution. Attention to this. This is a repeated solution for the characteristic equation. Again, note that because r squared is r times r, when we set it equals 0, this r can be 0 and this r can be 0. So 2 times r is 0. So this is a repeated root. Actually, the original characteristic equation is of degree 3. So it should have 3 different roots. But here we have only 2 roots. So this shows that one of the roots is repeated, which in this case, r equals 0 is the repeated root. Now that we have the roots, we can write the complementary solution. For r equals 1, the complementary solution is c sub 1 e to the 1x or x. But for the repeated root, the complementary solution is c sub 2 e to the 0x. But because it is repeated, we have to write the same thing multiplied by x, c sub 3 x e to the 0 x. Note that the characteristic equation is of degree 3. So in the complementary solution, we have to have 3 solutions, 3 different terms. 1 term, 2 term, and 3 term. And again, because this root is repeated, we have to use the formula related to repeated roots for the complementary solution. If you are not familiar how we write the complementary solutions, you can watch my video about solving homogeneous differential equations. Before we go for particular solution, let's simplify this answer. C sub 1 e to the x plus e to the 0. Note that 0 times x is 0. E to the 0 is 1. So we can write this as just c sub 2 plus e to the 0 again is 1. 1 times x is x, so c sub 3x. So this is the complementary solution. Now we want to find the particular solution with the method of undetermined coefficients. The y particular is, note that in the right side of the equation, this function is a polynomial of degree 1. We have 6x to the 1 plus 12. And because this is a polynomial, we guess that the function that we are looking for here, that second derivative of that function the third derivative of that function minus second derivative of that function, it should be this. So it makes sense to suppose that function that we are looking for, the particular solution, to be again a polynomial in the form of ax plus b. This polynomial is degree 1, so we suppose the particular solution to be of degree 1. If this was of degree 2, then we suppose the particular solution to be of degree 2 in this form, and so on. But here we have of degree 1 here, so the particular solution is of the same form and the same degree. But don't forget, as I mentioned in the other videos, when you use the method of undetermined coefficients, always you have to check the terms in the particular solution with the terms in the complementary solution. If any terms here appears and duplicates here, to prevent this, you have to multiply the particular solution by x, or the higher degrees of x, like x2, x3. So you have to multiply this by a degree of x that prevents the duplication. Here, ax plus b is repeated exactly here. If you look at ax, we have c3x, the same form, the same function. It is repeated. And also b is repeated here. B is a constant, and c sub 2 is also a constant. So we have common terms between our particular solution and the complementary solution. To prevent this duplication, we have to multiply this by x. But if you multiply this by x, then we have ax2 plus bx. Again, if we check this expression, you can see that this one now is not repeated here. We don't have any x2 here. But bx, don't care about b, just focus on the variable part, x. Here we have exactly x in this term. So still, by multiplying x here, we have duplication. So x is not useful here. We have to multiply by a greater degree of x. So x to the 1 doesn't work, multiply it by x2. If x to the 2 doesn't work, multiply by x3, and so on, till nothing here duplicates here. Let's see if we multiply by x2, what happens. Then we have ax to the 3 plus bx2. X to the 3, we don't have any x to the 3 here, and x to the 2, we don't have any x to the 2 here. So now this is the form of the particular solution. And as you know, a and b are the undetermined coefficient that we want to find. So the form of the particular solution for this differential equation, this third order differential equation, is this. Before finding second derivative of this expression and the third derivative of this expression, it's better to multiply x2 in the bracket, and this helps you to get rid of the product rule of derivatives. This makes finding derivatives easy. So y sub p is ax to the 3 plus bx to the 2. If we take derivative from this expression, this equals 3ax2 plus 2bx. The second derivative is 6ax plus 2b. And finally, the third derivative equals 6a. Now, if we plug in 6a for y triple prime, we have 6a minus y double prime, which is 6ax plus 2b equals to the other side of the equation, 6x plus 12. We can write the left side as 6a minus 6ax minus 2b equals 6x plus 12. Now we can equate the coefficient of corresponding terms in the left with coefficient of the terms in the right. If you look at the right side of this equation, the constant term is 12. But what is the constant term in the left? 6a minus 2b. Note that in this term we have x, so this is not a constant term. So 6a minus 2b must be equal to 12. What is coefficient of x here? 6. What is coefficient of x in the other side of the equation? Negative 6a. So negative 6a. From this equation, a is negative 1, which if we plug in negative 1 here, 6 times a, 6 times negative 1 is negative 6, minus 2 times b equals 12. If we move negative 6 to the other side, we have 18, 12 plus 6 is 18, which if we divide by this negative 2, 18 divided by negative 2 is negative 9. So from this equation, b is negative 9. Now that we have the value of a and b, the particular solution can be written as negative x plus b is negative 9 times x2. So this is the particular solution of this differential equation, which if we add the particular solution to the complementary solution, we can find the general solution. Y is the general solution. So y equals to complementary solution c sub 1 e to the x plus c sub 2 plus c sub 3 x plus the particular solution, which is negative x minus 9 times x2, which if you like you can multiply x2 in the bracket. So this is the general solution of the differential equation. Let's do one more example. The differential equation is y triple prime plus y double prime equals 3e to the x plus 4x squared. The general solution, as usual, is the sum of complementary solution and the particular solution. For finding the complementary solution, First, we write the corresponding homogeneous differential equation, which is this equation, y triple prime plus y double prime equals 0. For solving this homogeneous differential equation, first we write the characteristic equation, which is r to the 3 plus r to the 2 equals 0. Okay, let me actually make this example a bit harder. Put a negative here in the exponent of e to the x. So we have e to the negative x, not e to the x. This makes this example a bit more tricky. Okay, let's continue solving the equation. R to the 3 plus R to the 2 equals 0. Now if we factor R to the 2, we have R plus 1 equals 0. From this equation, R squared is 0 and R plus 1 is 0. From this equation, R is negative 1, a simple root, and from this equation, R is 0. But again, similar to the previous question, this root is a repeated root. Don't forget this, because this root is the root of a quadratic equation. And because we have only one root for a quadratic equation, this root is a repeated root. Now, based on these roots, we can write our complementary solution. The complementary solution is c sub 1 e to the negative x plus c sub 2 e to the 0x plus c sub 3 x e to the 0x. We add this here because this root is a repeated root, which if we simplify, we can write our complementary solution as c sub 1 e to the negative x plus c sub 2 plus c sub 3x. E to the 0 is 1 times c sub 2 is c sub 2, and this is 1 again, so we can write this term in this form. Now that we have our complementary solution, we can write the general form of our particular solution. Note that in this differential equation, the function in the right side is two parts, 3e to the negative x, which is an exponential function, and 4x to the 2, which is a polynomial of degree 2. So we have two parts which we have to consider separately for writing the particular solution. This part is a simple exponential function, a constant multiplied by an exponential function. Based on this, we can guess that the particular solution would be a constant undetermined coefficient times by e to the negative x. The function that we guess second and third derivative of that would result to this is something like this, a constant unknown times e to the negative x. But if we compare this with the solution that here we have, the complementary solution, we can see that e to the negative x is exactly repeated here. But we know that this should not happen. We have to prevent this duplication. How we can prevent this? We multiply the particular solution by a degree of x to prevent duplication. If we multiply this by x, if we multiply this expression by x, let me add x instead of here in the middle between a and e to the negative x. So fortunately we have a space here, so a x e to the negative x. By adding, actually multiplying x in our particular solution, now this term is not repeated here. So now this is the correct form for the particular solution. Now we have to go for this part. 4x to the 2 is a polynomial of degree 2. And because we have a polynomial of degree 2, we guess the particular solution to be a quadratic form, a polynomial of degree 2. So something like not a, b, because we use a here, so we cannot use a anymore. So say bx2 plus cx plus d is the general form of a polynomial of degree 2. But comparing this with our complementary solution, we can see that we have terms common between this and this. Some of the terms here appeared here. Again, to prevent this, we have to multiply this part. Note that this part is separated from this part. This part is related to this, and this part is related to that. Okay. How we can prevent duplication? We multiply this by x, x2, x3, so on, till none of the terms here appears here. We have x and we have x here. So, to prevent this duplication, we have to multiply this by x first. But multiplying by x is not enough, because if we multiply x in this bracket, again we have dx, which we have x here. Because we have x to the 1, d times x to the 1 is a term with degree 1, which exactly we have x to the 1 here. So x to the 1 is not enough here. So we have to multiply by x2. And multiplying by x2 prevents duplication. If you multiply x2 in these terms, none of the terms now is repeated here. We have bx to the 4, cx to the 3, dx to the 2. And we don't have any x2 here. So, for this part, x was enough. But for this part, x to the 2 prevents duplication. Now that we have the general form of our particular solution, we can find a, b, c, d by finding second and third derivative of this and substituting here and setting coefficients equal to each other. Let us start. Y prime equals to, for finding derivative of this, we have to use product rule, because between ax and e to the negative x we have multiplication. Derivative of ax is a times e to the negative x plus, write the first function, which is ax, times by derivative of e to the negative x. Derivative of e to the negative x is the same function multiplied by derivative of negative x, which is negative 1. So derivative of second function is negative e to the negative x. So let's make here negative, this is better, negative ax e to the negative x. And for finding derivative of this part, it's better to first multiply x2 in the bracket and then take derivative. So, before taking derivative, actually let me delete this. First, before taking derivative, we write our particular solution in this form. And then we take derivative from that. Derivative of this term, as we see, is e to the negative x minus ax e to the negative x plus 4bx to the 3, 3cx to the 2 plus 2dx. The second derivative, y double prime, is derivative of this is simply negative a e to the negative x, because a is coefficient, we write a and we take derivative of e to the negative x, which is negative e to the negative x. For finding derivative of this, we do the same as we did here. Derivative of this, we have to use a product rule, and based on product rule, derivative is negative a e to the negative x plus a x e to the negative x plus 6bx2, actually not 6, 12 bx2, 6cx plus 2d. And finally, the third derivative is derivative of this term is positive, because again, when we take derivative of this, we have a negative, don't forget this. So a e to the negative x plus a e to the negative x plus product rule for this part, a e to the negative x minus a x e to the negative x plus, what is the derivative of this? 24bx plus 6c. Now that we have the third derivative and second derivative, we can substitute them here. Y double prime plus y triple prime. So first let's write y triple prime. Note that we have a e to the negative x and a e to the negative x and a e to the negative x. So we can write it 3a e to the negative x minus ax e to the negative x plus 24bx plus 6c. And then we have to add this. Here we have negative a e to the negative x minus a e to the negative x, so we have negative 2a e to the negative x plus ax e to the negative x plus 12bx2 plus 6cx plus 2d, and all of this must be equal to, all of this expression should be equal to this 3 e to the negative x plus 4x squared. But note that this term and this term cancel each other. And 3a e to the negative x minus 2a e to the negative x is a e to the negative x. So first let's simplify this a bit more. This minus this equals a e to the negative x. This term and this term cancel each other, so nothing from them remains. We have 24bx, and also we have this term here with x, and we don't have any other term with x. So we have 24bx plus 6cx, which if we factor x from them, we have 24b plus 6c times x. So again, this is cancelled with this. We simplified this with this. We have this constant and this constant. So let's put a bracket around both of them because they are similar terms, they are constants. And the only term with degree 2 is 12bx2. And this should be equal again to this. Three e to the negative x plus 4x2. Now by equating corresponding equations, we can find a, b, c, d. What is coefficient of e to the negative x in the right side? 3. What is coefficient of e to the negative x in the left side? A. So a is 3. Very simple. What is coefficient of x2 in the other side? 4. What is coefficient of x2 in the left side? 12b. So 12b equals 4, which from here b is 1/3. Now, if you pay attention, what is coefficient of x here? We don't have any term with x in the right side. So coefficient of x is 0. You can think it as 0x here. So in the left side also, coefficient of x must be 0. So we said 24b plus 6c equals 0. But note that b is 1/3. 1/3 times 24, if you plug in 1/3 here, 1/3 times 24 is 8. Which if we take 8 to the other side, we have 6c equals -8, and from this c is -8/6 or -4/3. And finally, if you look at the right side, you don't have any constant term in the right side. But in the left side we have this, so this should be equal 0. So 6c plus 2d equals 0. But c is -4/3, which if we plug in here, 6 times -4/3, 6 times -4/3. If we cancel 3 with 6, 2 times -4 is -8. So from here, 2d equals 8. We move -8 to the other side, we have 8. And from here, d is 4. Now that we have the value of a, b, c, d, we can plug in these values here to write y particular. So y particular is a, which is 3, 3x e to the x. What is b? 1. If you multiply this in here, 1/3 x to the 4. So -4/3 x, which if we multiply x2 by that, we have -4/3 x to the 3. And finally dx, which is 4x2 plus 4x2. This is the equation. Now that we have the particular solution and the complementary solution, we can write the general solution. So general solution is the sum of complementary solution and the particular solution. So this equals to c sub 1 e to the -x plus c sub 2 plus c sub 3x plus all of this. 3x e to the x plus 1/3 x to the 4 plus minus actually 4/3x 3 plus 4x2. And this completes this question. I hope by watching this video you have learned how to find the complementary solution, the particular solution, and the general solution of non-homogeneous differential equations. If you liked this video, please subscribe in my channel and see you in the next videos.